Hello learners, good morning, good afternoon. My name is Vishvadeep and I welcome you all on Unacademy Computer Science Channel. As you all know that we are discussing since last 2 days some previous year questions on GATE in this particular series. Today is the third class of the same PYQ session and today we are going to discuss about linked list and its previous year asked questions in GATE exam. So stay tuned with this just because in this particular session I am not going to only solve the problems but I am going to explain you that how you are approach or how you are going to tough questions, how you are going to understand the question, and after that how you are going to solve those problems ultimately. So without failure, stick till the end, stay tuned till the end and you will learn a lot in this particular session. Before we go further, please here for the first time and if they don't know about me, let me introduce myself. My name is Vishvadeep. I have written GATE exam multiple times. Why? Just I wanted to know if I am teaching something, then I am good enough in that particular thing or not. How can I learn from GATE exam so that I can teach you that what to take care in the exam. For that I have written GATE multiple times. Before that, as a student also I have written 2 times GATE in third year and final year. Third year my rank was 682, final year 19. After that as a teacher I was writing the GATE 440 and there are few more ranks I am having. Went for my master's ME, Master of Engineering to IISc Bangalore, another master's from BITS Pilani in data science, a rich experience of teaching I am having since long. I am teaching to the engineers and these are the courses on Unacademy's platform I am taking. If you Academy from my end, from my entire steam end, then there are so many options you guys are having. What are the options you guys are having? First option is go to Unacademy's platform and you will be learning a lot. What you will be learning is out on Unacademy my profile, and on Unacademy in my profile you will be having special classes. On those special classes we are taking some special classes which are for free, so you can check out those special classes and those are absolutely free. Okay, fine. So check out those special classes which are free, but for that to follow my profile on the Unacademy's platform. If you want my all the specially taken special classes in organized manner, that all the theory sessions, all the practice sessions, all the CO sessions, data structure sessions, and everything in more organized way, go to this URL. You will be having one web page over there. I have organized all the previously taken classes of Unacademy. One more thing you can get here is 3 p.m. Today I am going to have one special class for revision of data structure. So if you're done with data structure course, or if you are learning data structure still, but if you have started few months, few days back, revision class 3 p.m. today, which is absolutely free. Yes, special class 3 p.m. on Unacademy's platform, which is absolutely free. You can join me and you can learn from there. Okay, got it. And another thing we have brought for you is this. That's a test series in which we are providing you quality question. Go for it and try to write the test. These tests will definitely test your understanding, your preparation with the most effective way, so that you can understand that how much you will have to prepare more so that you can get more marks you can in the examination. If you are really serious about your preparation and if you want that in the end, you need to have a boost of the preparation. You need to have some kind of a kick at the end of preparation. If you are writing for 21 exam, if you are going for 22 exam, and if you want key at the end in last 8 months or 10 months or in last 6 months, you don't want to go like do or die situation. If you don't want to have that do and die situation in last 6 months, 5 months of the preparation, then join Unacademy Plus. We will start your preparation now. You will not struggle with your preparation, so that the study will become smooth if you are going for 22, and definitely you will have a final boost in your preparation if you are going for 21 exam. So we will be having a different plan for both of the people, so that we can have the smooth and easy preparation for both of you. If you want to join Unacademy Plus, then you can get a discount if you use the code VDEEP10. This particular code will connect you, your preparation, with my team's hard work, so that this particular preparation, your preparation, will be on the perfect level. If you want to go for Unacademy Plus subscription, it is available in 24 months, 18 months, 12 months, 6 months, 3 months and 1 month subscription also. And if you are the person who need a personal coach facility from Unacademy side, means the coach, that fellow will give you preparation strategy, will make the planning for your irregular studies, will track your performance, will give you study booster session, will provide you test series analysis personalized only for you, and will give you extra material for the practice and specialized notes. If you want all these facilities, then you should go for Iconic subscription. This Iconic subscription has all the facilities of Unacademy Plus facilities, and this particular subscription also you can have using the discount if you use the code VDEEP10. This particular code you need to remember, you need to use this particular code so that you can get discount, plus you can connect your preparation with directly with my team's hard work, so that when these two will meet, your work, your preparation and my team's hard work, then you will have great outcome out of this particular preparation plan. So remember, you need to use this particular code VDEEP10, and you need to connect with the perfect preparation strategies. Fine. Okay, so if you are fine with this, let's go for this one. Let's go for this one and let's start the question solution. So today I have got some questions for you guys from the linked list chapter, and we are going to solve some questions on the linked list. You guys will be ready, and when you guys will be ready, then you need to give me the hint. Yes, you are ready or not? Ready or not? Ready or not? Let's go. Very first question, very easy one. 1987, बहुत पुरानी बात है यार, 33 years back from now. In a circular linked list organization, insertion of a record involves modification of. If you are inserting a record in a circular linked list, so what is circular linked list? Let's draw. Let's not talk in the air. Let's not talk in the air directly. हवा में बातें नहीं करने का, हमको क्वेश्चन सॉल्व करने का है, तो बना लो, ये रहा लिंक लिस्ट. And in this particular linked list, suppose this is your list pointer pointing to the first node, circular list pointing to the last node. Now, how many pointers you are going to update, or you are going to modify when you will be having an insertion of a record? So anywhere you insert a record, suppose here you are inserting a record, so one pointer is this one and one pointer is this one, you are going to update. Right? If you are suppose inserting an element here, then how many pointers you will update? One is this one and one is last one. So ultimately you need to modify 2 pointers so that you can insert a new node in the circular list. You can insert 2 nodes. Fine. Now next question number 2. Question number 2, it was very easy, बहुत आसान सा क्वेश्चन था. Another question, here it is. Question number 2, 1993, very old. शायद आप तो आए नहीं होंगे दुनिया में, आपका बर्थ भी नहीं हुआ होगा, तब का क्वेश्चन है. चलिए देखते हैं. Consider a singly linked list having n number of nodes. The data items D1, D2, D3, D4 up to Dn are stored in these n nodes. Okay, so the linked list is like this. कि first node is having data item D1, then second node is having data item D2, then similarly you have n number of nodes, last node is having data item Dn. Okay, got it. Let's x be a pointer to the jth node, 1 less than equal to j less than equal to n. So there is a pointer j which points to some jth node, suppose to this node in which dj is stored. Fine. So I have taken js2. So d2 is stored on second node. Fine. A new data item d stored in node with address y. So there is a new data item which I have inserted in a new node. The data item is d and address pointed by y. So address of this particular node is in y with address y. Okay, fine. Address y. Okay, fine. So this particular address y of this particular node we are having. Now further, give an algorithm to insert d into the list to obtain a list having data items d1, then d2, then d3, dj, and after that d. Means after the dj node, I need to insert the new node which is having data item d and then rest of items as it is. Which means it's very simple thing. After this node j, which is pointed by x, so x is holding the address of this particular node, y is holding the address of this particular node. After this node I need to insert this particular node. So what should I write? The algorithm. First of all, I need to update the link pointer of this newly inserted node. So how can I change the link pointer of this particular node? I should write the algorithm like this. Key y node pointed by this y pointer node's link part. Next part I'll have to update. If suppose after this node will be inserted, after this node which node comes? The data item with d3 node comes. Data item with d3 nodes comes, and how can I get address of this node? By x ka link. So y link is equal to x link. Got it? Is that clear? Is that clear? So x link will be copied. This address, this node's address copied here, this link updated. Now what should I do is I'll have to update this pointer also, so that next of x can be y. How can I make the changes? I will make the change like this, x ka link. What should I write? What should I write? X link is equal to what? X link is equal to what? What? X link is equal to y. So this will be the algorithm. My work done. Why my work done? Now without using the header. Yes, I haven't used the header. Look at this. I haven't used the head pointer or header of the list. I haven't used the list pointer at all. I have used only x pointer, y pointer, and my work done. My work done. Great, amazing, amazing, amazing. क्या बात है, क्या बात है. बहुत सारे लोगों को बहुत कुछ पता है. Amazing, superb. Got the answer. Should we go for the next one? आगे बढ़ेंगे क्या? Next question, question number 2 coming on your way. Here it is in front of your screen. Very, very simple. Linked lists are not suitable data structures for which of the following problems? इनमें से किस प्रॉब्लम के लिए डेटा स्ट्रक्चर इज नॉट अ सुटेबल प्रॉब्लम? एंड आई शुड गो विद आंसर बाइनरी सर्च. Why not for binary search? If you are aware about the binary search, then in binary search what we do for the searching in a sorted list, we reach to the middle element. We reach to the middle element. And we check if our element which we are searching is present on middle element or not. In the linked list, we cannot reach to the middle element directly. We cannot reach to the middle element directly. Why? Just because linked list is a sequential access list, we cannot jump directly to the middle element in the linked list. We can't apply binary search with efficiency. With that same log of n time I cannot apply. That's why linked lists are not suitable for binary search algorithm. Yes, you have given the correct answer. Superb, amazing, 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 amazing. Nishu, Bhaskar, Rajendra, Anurag, and Saudagar. Amazing, superb, superb. Look at this. Another question, another question. Next question. Here it is in front of your screen. Be ready, concentrate, and here it is another question. It says, which of the following Which of the following statements is true? As the number of entries in the hash table increases, the number of collision increases. Yes, it can be a true statement. Recursive programs are efficient. Say that. Always true? No. Might possible true, might possible false. The worst case complexity for quicksort is big O of n square. Yes, that is true. That is true. Binary search using a linear linked list is efficient. अभी तो बताया नहीं है. अभी just now I explained you it is not. Just now I explained you it is not. So first and third seems to be correct. Yes, D is looking correct. क्या बात है, क्या बात है, लोगों को आंसर्स भी पता है. बहुत क्विक, बहुत शानदार, अमेजिंग अमेजिंग. Binary search using a linear linked list is not efficient. Wrong. So only first and third are true. That's correct. Let's go. Next question. The concatenation of two lists is to be performed on big O of one time. So you have two lists and you need to concatenate those two lists. Concatenate means at the end of one list you are adding another list. Which of the following implementation is of a list should be used? Okay, so if we use singly linked list, suppose, okay, let me take singly linked list example. These are two singly linked lists I have taken. And I need to concatenate these two lists. I need to concatenate these two lists. This is list number 1 and this is list number 2. If I want to concatenate these two lists, how to concatenate? I need to reach out to end of the first list and then last node of the first list will point to the first node of the next list. Like this way you can concatenate. But concentrate on this particular statement performed on constant time. Can I reach to the address of the last node in constant time? No. In the singly linked list, I cannot reach to the last node directly. Yes. Now, if A option is gone, then of course we can eliminate D option also. Array implementation of list. Again, the same problem happens. If you have array implementation or linked representation, whatever, the only problem with us is in the constant time, I cannot reach to the last node. हम last node तक नहीं पहुंच सकते. If we cannot reach to the last node means D option gone, A option gone. Now if we have doubly linked list, if we have regular doubly linked list, then can we get the address of the last node directly? Mushkil hai. If we are maintaining a separate pointer using the doubly linked list point, sometimes we maintain two pointers, first and last. If we are maintaining the address of the last node in some pointer, yes, concatenation is fine. But if we don't maintain the last node's address, if we have the doubly linked list like this only, that we are maintaining only one pointer, we are not maintaining the last address, last node's address, then what happens in that case? What happens in that case? In that particular case also, to get the address of the last node, the same end time is required. So doubly linked list is also gone. Can we go for circular doubly linked list? Yes. In the circular doubly linked list, the first node circularly will have the address of the last node in the previous pointer, and last node circularly will have the address of the first node in the next pointer. So when we have circular doubly linked list, in that particular case, to get the address of the last node, constant time is required. So I am going with option C. I am writing the statement for your future references in circular doubly linked list. In circular doubly linked list, address of last node can be obtained from first node in constant time. In constant time. Got it? Got it? Got it? Okay, there is a question. Sir, what is D option? Can you give a rough idea? Okay, fine. So, okay, let me explain you the array implementation of list. आपको नहीं पता है? Okay, no problem. I will tell you. I will teach you array implementation of list. Will that be fine? चलेगा? चलेगा? रिटर्न में मुझे क्या मिलेगा? What I'll get in the return? 2 marks extra in the GATE exam if such kind of question can be asked. Okay, look at this. Look at this. Suppose we have a list like this. We have element first A. Then we have element on the next is some M. Then next element we have is D. 3 elements are there. Okay, let me take another element. Let me take another element. Fine. Another element, suppose B. B और D confusion हो जाएंगे तुम्हारे. Let me take F. These are the 4 elements in the list. Fine. Array implementation of list says that you will be having 2 arrays. You will be having 2 arrays. जी हाँ, आपके पास होते हैं 2 arrays. First array will be having the data items. Second array will be having the links. First of all, your list index will hold the address or actually index of the very first element. Suppose first element is present on index number 2. So you have 4 elements. So I am taking 0, 1, 2 and 3. 3 indexes in this also 0, 1, 2 and 3. So look at this. On index, list index is 2, means on index number 2. On index number 2 you are having your first element in the data array and its link of the next element present. Suppose link of the next element present is 0, which means next element is present on your index 0 in the data. So in the data item on index 0, next element should be present, which is M, and on the next in the link part index, next element's index will be there. If it is index 3, means on index 3 next item D will be present and it will hold the address of what? Address of or index of next element. So index should be 1 for the next element. Next element on index number 1 is stored, which is element F. So F is stored on index number 1 and here we will be having link. Nothing is there, so we can keep -1 here so that it shows the end of the list. Like this way you can have the array implementation. 2 arrays are there. If you want to access the data part, it will be in data part on this index 2, and if you want to have the link, it will be in the links array in the same index. So index 2 is holding F and its next index 2 is having hold A, first element, its next index and 0, next element at index 0, M and link. Similarly you can have, or you can expand this for a larger list also. Clear now? Linked list representation in the array. Clear now? Clear. नींद आई, भूख लगी? चलिए, good. Okay, very welcome everybody, very welcome. How are you all? If you haven't liked the session, please like the session को like कर दो. और another question. Oh, it's a very big question. It is a very big question. बहुत बड़ा दिख रहा है, tough भी दिख रहा है. Let's see. Let's try to understand the question. Even I don't know how to solve the question. I will read in front of you and I will try to solve the question. Okay, now. Fine. Okay, one question is there, sir. -1 की जगह null भी लिख सकते हैं. The only thing is ये links जो array है इसमें रखेंगे हम index value. अब index value अगर integer बनाई है तो integer में null कैसे रखोगे यार? The only problem is these are what? These are क्या है? ये क्या है? वो क्या है? क्या है ये? इंटीजर, ये कैरेक्टर एरे ले लिया, ये इंटीजर एरे ले लिया, क्योंकि इसमें रखेंगे इंडेक्स, तो अगर इंडेक्स रखेंगे तो नल कैसे रखेंगे? चलिए क्वेश्चन सॉल्व करते हैं। अगला प्रश्न ये रहा आपके सामने। कंसीडर द फॉलोइंग पीस ऑफ सी कोड फ्रेगमेंट दैट रिमूव्स डुप्लीकेट फ्रॉम एन ऑर्डर्ड लिस्ट ऑफ इंटीजर्स. Ordered list of integers means the list is having ordered elements. Ordered elements means sequentially arranged elements. Okay, so let me take a particular list. Let me take a particular list. Pointer is head given here, so head is pointing to the first node. First node is suppose having element 1, then next 1, then next 2, 2 and 2. This is the order list I have taken. It will remove the duplicates. Fine. So I have called the function with remove duplicate with j, integer j and head. What is star j? I don't know as of now. So j is a pointer. J is a pointer pointing to some integer. And head is a pointer pointing to the first node of the list. Fine. Node star t1 and star t2 and star j is equal to 0. So initially I have taken j star j is equal to 0, means j is pointing to some kind of integer. I have taken it as 0 and head pointer is pointing to my first node, and two more pointers I have taken t1 and t2. The easiest and always effective, most efficient method to solve any programming question is execute the statements one by one. Take one statement. I know you guys are at least that much intelligent कि you can understand the statement, that what is the meaning of that statement. That will be more than enough to understand entire program. You don't have to understand the program. You don't have to understand the logic of the program. If you can run the program by one statement, that will be enough. That will be enough to get the answer. I do the same thing till now, even though after teaching the engineers the programming for more than 13 years, I still do the same thing for any new question, just because I don't want to miss any small trick given in the question. So I don't put any kind of intelligence or smartness while solving the question. Understand one statement, go for it. That's it. आगे बढ़ते हैं. T1 is equal to head. So T1 pointer is pointing to the first node. Fine. Whatever is there in head, that is also there in pointer T1. If T1 not equals to null, yes, T1 is not equals to null, true, then T2 is equal to T1's next. T2 here. Fine. Else return head. No, not else. Go down. Star j is equal to 1. So already we have a node. So star j is equal to 1. If T2 is equal to null, no, it is not equals to null. Then while, okay, so we need to run a code. While T2 not equals to null, till T2 becomes null. Okay, right now T2 is not null. Fine. If T1 dot well is not equals to T2 dot well, means T1 की वैल्यू और T2 की वैल्यू अलग है. If we have T1 and T2s pointing to two different nodes and both are having two different values, then I will go inside if. Right now both are pointing to some nodes which are having same equal values. Equal values. So if equal values, then I will go into I will not go into the if part. I will directly execute this. T2 is equal to T2 ka next. T2 is equal to T2 ka next. Come here. Still inside the loop. Yes. Go up. T2 not equals to null. Yes, true. Go down. If T1 dot well is not equals to T2 dot well, T1 dot well is equal to T2 dot well. No, not equals to T2 dot well. Yes, values pointed by T1 and T2 are now different. So we will go inside. We will go inside and what it is there? Star j is equal to j plus plus. Now you have j plus plus. Fine. T1 ka next is equal to T2. So T1 ka next, this one. T1's next, updated by T2. Fine. So middle duplicate node gone. Directly T1 is pointing to T2, and then T1 is equal to T2. T1 comes here. T1 is equal to T2. Fine. After that, once if is done, T2 is equal to T2's next. T2 becomes here. Next, go up again. Condition T2 not equals to null. Yes, true. Inside we are going. T1 dot well not equals to T2 dot well. No, equal. Then outside T2 equals to T2 ka next. T2 here. Then go up again. T2 not equals to null. Yes, true. Come inside T1 dot well is not equals to T2 dot well. No, equal to. Values pointed by T1, value pointed by T2, both are equal. So if true, no, false. T2 equals to T2 ka next. Okay, now T2 equals to T2 ka next means T2 becomes null. Go up again. T2 not equals to null, condition false. Come out. What it says, T1 dot next is equal to null. So T1 dot next becomes null here. This link gone. Return head. So you can check out what is there in the head pointing to 1, and 1 ka next is 2 and 2's next is null. All the duplicate nodes removed. Fine. Now assume the list contains n elements, n greater than equal to 2. Fine. How many times is the comparison in statement S1 made? So first of all, T1 was here, T2 was here, 1 comparison. Then T2 gone here, 2 comparisons. Then T2 gone here, 3 comparisons. Then T2 gone here, 4 comparisons. And after that T2 gone out means only 4 comparisons you had. Only 4 comparisons you had. So if initially n number of elements you had, then number of comparisons in S1 was n minus 1 comparisons. Good, somebody has answered also. Great. Bhaskar, nice, amazing. So number of times comparison in the statement S1 is made is n minus 1 times. So what we do is we start our T1 from the first node and then T2 from the second node, and then T2 will go from the second to third to fourth to fifth, sixth, seventh, eighth up to nth node, and we are comparing T2 with previous T1. So T2 is starting from second node to the last node, and we are comparing it with the T1, which means T2 will be going from second to nth, means n minus 1 nodes T2 will point, and those many comparisons you will make here in S1 statement. Good. Now, next is, what is the minimum and maximum number of times the statements marked S2 get executed? S2 get executed, this one means how many times this particular condition can be true and how many times this condition can be false. When this condition is true, you will execute this statement S2. Yes. So maximum how many times you can come for the condition inside the condition. Look at this. You are comparing this if maximum n minus 1 times. If maximum n minus 1 times you are comparing, and every time if the condition is true, you are going inside. See, this comparison you are doing n minus 1 times. You already done that. You have already checked that. Yes, n minus 1 times if you are checking it, and if every time condition is true, possible? Yes, possible. Means every element in the list is having no any duplicate. All unique values, all unique values. You can run the condition for each unique value. For all unique value, this particular condition will be true. In that particular case, this particular condition will be true n minus 1 times maximum, and this S2 will run maximum n minus 1 times. Maximum n minus 1 times. So maximum this S2 can executed is equal to n minus 1 times. Just because n minus 1 times you are comparing these two values, and every single time this condition can be true. Vice versa is also true. Every single time this condition is false. Every single time this condition is false. So I am talking about answer B. For answer B, if I want maximum value, means condition in statement S1 is true every time, which means maximum n minus 1 times S2 gets executed. S2 gets executed. And this particular condition says all unique values in the list. All unique values in list. And similarly, if we want to go for minimum times, then every time condition is false. Every time condition in the statement S1 is false. Condition in statement S1 is false every time. If condition in S1 is false every time, which means you have all values duplicate. Means only one unique value in entire list. Only one unique value in entire list, remaining all the values are duplicate. In that particular case, how many times S2 will be executed? 0 times the S2 will be executed. Yes, 0 times S2 will be executed. So maximum is n minus 1, minimum is 0, and what is the significance of the value in integer to pointed to by j when the function completes? So what this particular j is pointing, j is giving you the total number of elements remaining after the removal of duplicates. So how many unique values are there after removal of duplicates? That will be given by the value pointed by j. Yes. So what I should write for this one? I'll be writing the answer for this particular C. It holds number of nodes in final list after removal of duplicates. Or you can say total unique values. Number of unique values in your original given list. Got it? समझ में आ गया क्या आप लोगों को इतना? Did you get it till now or not? All the members who have joined little late to us, अगर आप लोगों ने ये सेशन लाइक नहीं किया है, so please like this session. Did you get till now? If you got it, let's go for another question, which is again very simple question. 1998, another simple question. Here it is in front of you. Next one, let P be a pointer as shown in the figure in a singly linked list. So this is P pointer. Okay, so I am making it even larger. This is pointer P. What do the following assignment statements achieve? So there are some assignment statements given. P is pointing to this cell. What exactly happens after this execution? Let's try. Q is equal to P is next. So P is this, Q is equal to this, next. Fine. So Q will be pointing to next. Now P next is equal to Q's next. So whatever is there in the Q's next, address of this particular node assigned into P's next. Fine. Now. Q's next ka next. Q's next means address of this node. I'll have to point in, or I'll have to store in Q's next. So this particular node's address I'll have to copy in the next of Q. Next of Q, like this way. And then P's next ka next is equal to Q. P next and its next is equal to Q. So its next is equal to Q. Now look at this. Let me take some values. A here, B here, C here, D here. So right now P is pointing to a node which is holding the value A. After that, A's next is C. Then C's next is element B. And then B's next is D. Q is still pointing to this node. What exactly it did? What exactly it did is, whichever the node P is pointing, its further two nodes, its next two nodes are swapped. Swapping of next two nodes of P. So if P is pointing to this node, then it is swapping P's next and its next node. Look at this. This and this node swapped. So I am writing swapping of two nodes which are next of P and next to next of P. So P is after P, we have two nodes. Yes, next two nodes of P after P we are swapping. Okay, fine. There is a question of COA, sir, who designs ALU control units, sir, who knows how software is created from hardware? It is ECE engineers or CSE? One, I am BTech first year. So Subhrajyoti, it's totally combined thing which you are talking about. If you want to go for CPU designing, then you can go for hardware work along with the ECE engineering also, in the CSE engineering also. But for that design work, you need to work in the hardware domain in your masters, or you need to go for your BTech in really great college, so that you can learn how the hardwares are designed. If there is a specific branch called as microcontroller branch. In that you can learn how to design these. That comes under specifically ECE, but there are some CSE course also there in that particular domain. You can go for it and you can learn. Next question, 1999. Write a constant time algorithm. Okay, to insert a node with data item D just before the node with address P of a singly linked list. ओहो, ये तो हमसे illegal काम करवाना चाहते हैं. These people want to have some illegal work done. Suppose we have these items already. We need to insert a new node with data item D. Here, suppose a pointer P is given to a node. Before this data item C, I need to insert this. But if I want to insert before this data item, or this pointer P is pointing to a node, before this node, if I want to insert this new node, I need to make a change. What change? This B should point to this node. And do I know the address of this node? No. Can I get it from pointer P directly? No. Now, Now, what is the problem? I cannot get address of B directly, address of this node directly from P in constant time, means from starting I'll have to traverse till this predecessor of P, which takes big O of n time. Which takes big O of n times, means this particular procedure will not help. This particular procedure will not help. So what I will do, I'll have to think something out of box. I'll have to think something out of the box. What I will do is I will keep this particular data D here and this particular new data C here or previously present, and I will insert the new node after this node. So the data items will be in the order A, B, then D, then small c, and then D. So what exactly I'm doing, what exactly I'm going to do is I will insert the new node after P. I will insert the new node after P and I will swap the values. So what I am going to do is I am going to do this. New node, suppose new node is having its address in N. So new node's link pointer or next pointer I am updating by P's link pointer, so that this particular link is established. After that, P's link I am updating by this N, and once this insertion is done, after that I will swap these two values. So what I'll do, in a temp character value I will take pointed by value P the data item, then P ka data I will update by N's data, and at the end I will update this N's data by temp. So swap the values so that we will be having data item D here and data item C here. Done. If you want to look this particular entire procedure legal, you can do one thing at the end. You can change pointer P also by N, so that I can say, see, pointer P is here, it is holding the data item C, and before that I am having new node which is having data item D. Right? So I am having some kind of illegal work. In constant time I can do this particular operation as they have asked, and new item is inserted before the element or before the node. Yes, it was having element C. Yes, before that I have inserted item D. Yes, done. Gone. Yes. Fine. Got it. Understood. So what they asked, उन्होंने क्या कहा कि एक नोड दे रखी है पॉइंटेड बाय P, इसके पहले एक नई नोड इंसर्ट करनी है, कर दिया, विद डेटा आइटम D हो गया, डन. यस. नाउ नेक्स्ट क्वेश्चन. In the worst case, the number of comparisons needed to search a singly linked list of length n for a given element is. अगर एक you need to search a singly linked list for n number of elements. So singly linked list is there with n number of elements. You need to search an element. Then in the worst case, how much complexity is needed? Answer is Dn. How? First of all, you will compare the searching element at first location. If it is present, well and good. If it is not present, go to the next. Then compare. In the worst case, you will compare all the elements of your given list with the data items to search. Because of that, comparisons will be n. Hence, complexity will be n in the worst case. Very simple, very simple. This question was one of the simplest question, 2002 ka GATE ka question. Look at this. Now see, when you try When you try to learn some course, suppose you have learned data structure along with me in last 15 days, 20 days or 1 month, and then immediately you solve the question, you seems like gate mein itna easy question aata hai, almost all the questions are easy, only few are tough, then why I cannot solve the questions, why I cannot get the answers? The problem is you cannot get the answer just because once all the courses are done, once you were learning the course, you remember the topics, you remember the concepts, then you can solve the question easily. But once the courses are done, 3 months are gone, 40 days, 50 days are gone, you haven't touched the course, and hence the problem occurs. The problem is, remember, you don't remember, your memory works on the concepts of stack. You can access only last inserted element. So in the previous few days, whichever is inserted, you remember, you can access all the elements which have gone to the bottom, not ever accessed. So you need a proper revision for those one. Revision. If you revise the courses properly in the better efficient manner, you will be able to remember the topics. See, if you are revising the topics and still you cannot remember, then again there is a problem in your revision strategy, in your revision planning. So you need to remember the topics, concepts, and small details of each and every concept. Then only you will be able to achieve good rank in final exam. Otherwise, even though you remember or you understand every single thing, even though you are the topper in your test classroom or whatever, finally you will not be able to get a good rank just because there you forgot every single thing. So you need to have a proper planning. Whatever you are studying, if you have covered only 80% of the course till the end, but still you remember every single thing about that, then you will have a higher chance to get more marks in the GATE exam instead of those members who have covered everything in the classroom, but they did not remember the things. Got it, got it, got it. So for that, I am having a very special session tonight on YouTube on the same channel. That session is going to help you guys that how you can make your revision plans. So you can come for that particular session. You can ask me the question that this is your status. What can be the best plan for you? I will give you little bit time to make little bit personalized session. I cannot hear every single student's query, but yes, definitely if general query somebody will be sending, definitely I will give you some specialized plan for your revision so that remaining last 3 months you can make best out of those things. So tonight I am having a plan. That particular plan is that particular session's timing is 10:30 p.m. So 10:30 p.m. don't miss that particular session. You need to come live. You need to ask your friends to come live so that you guys can learn a lot from that particular planner which I am going to present in front of you. बहुत बहुत अच्छा सेशन होने वाला है. प्रेजेंट हो जाइएगा आप सब लोग. अभी क्वेश्चंस खत्म नहीं हुए हैं बॉस, क्वेश्चन बचे हुए हैं, अभी और भी क्वेश्चन बचे हुए हैं. लुक एट दिस, another session, another particular question. What it says, consider the function f defined below. Okay, this is the function. For a given linked list P, the function f returns 1 and only if. 1 if and only if and only if. So first of all, let's try to understand what is the function. This is the structure, item and next pointer. Fine. This particular f function you have called for the list pointer P. You are checking if P is equal to null, means zero number of nodes you are having, empty list you are having, or P next is equal to null, means you are pointing P as first node and its next is null, means only single node is present. If P is pointing to null or P's next is null, means single node is present. In that particular case, this condition is true or this condition is true. Or if you have 0 nodes or 1 nodes, or if you have more nodes, then you need to have this condition true. This condition says P ka data less than equal to P ka next ka data, and same thing holds for entire list recursively. So if you have 0 nodes, right, then it returns true. if you have one node in the list, then it returns true. And if you have more than one nodes, greater than one node, then nodes to be having the data item in such a way कि this particular node should have data item 5, then it should have next data item should be greater, means this current node should be having data item lesser than this, then only this condition can be true. Lesser than or equal to, less than or equal to. So if it is 7, it can be 7 or greater than this. So if you have more than one number of nodes, then you can have the more than one number of nodes in such a way कि first node, whichever the first node you have, its next element should be having greater or equal element than this, the next should have greater or equal element than this, then only all these options, in all these conditions, this particular function can return you true. So the list is empty or has exactly only one element. A option is true, I will say false. Why? Just because this if and only if you have 0 element or 1 element, then only this linked list can give, or this function can give you true, otherwise never. No, if you have more than one item also, then to this list can give you true if you have list arranged in such a way कि items, next item should be greater or equal to the previous element. Next, the element in the list are sorted in non-decreasing order. Yes, that seems true. Non-decreasing order means equal or increment, equal or greater, equal or greater. Next element should be either equal or greater. Yes, that seems true. Non-increasing, no. Not all elements in the list have same data value. No, not at all possible. I am just comparing only next two elements. That's it. So answer should be B. Answer should be B. Okay, clear, fine. So one person says, sir आपकी क्लास इसी टाइम पे होती है? मेरी क्लास का जो शेड्यूल है वो ये है, 10 AM को मेरी क्लासेस होती है डेटा स्ट्रक्चर की, in which I teach data structure. Today we have taken a class on the tree traversal. Then we have 12 PM classes for PYQ on data structures on the YouTube. Then today we have 7 PM classes of COA crash course. And in that crash course, I am going to talk about very special thing, which is magnetic disk. These all are the sessions today I am going to have on YouTube. All 3 sessions for you, free live YouTube. Another session I'm going to have today 3 PM, which is revision of data structure. If you have studied data structure along with me or somewhere else, you can have revision of data structure at 3 PM, and this will be on Unacademy special class. So all these classes are for free for you guys. Come live, join live, enjoy with me, live and live. Okay, fine. These courses are going to be changed very soon on the crash course. Before that, I can tell you 3 PM classes are going on for engineering math. You can attend these classes. Pallav Gaur sir is taking the classes, and those classes are amazing, seriously amazing. These 3 courses are going to be changed very soon. Stay tuned to the channel and you will get this particular information that which course is coming next. Other than that, this particular team is working hard for you guys. Please help these people to reach out maximum number of students, so that maximum students can be benefited out of this. As many as times you can share the links of the lectures, playlist and the channel to maximum number of students on your social media, on anywhere, whichever media through which you are connected with the other students. If you want the PDF of the classes, then this is the channel Unacademy Gate CS. Join kar lena on the Telegram so that you can get PDF of all my lectures. And there is another opportunity for you guys to be connected with us. Facebook के पेज हैं, कनेक्ट हो जाओ हमसे ताकि आपको मिले अपडेट्स और बहुत सारे अलग अलग टाइप के कनेक्शंस. And then these are the channels my family, our Unacademy family, is providing to you guys. You guys can help these channels also to be connected with their respective students. For electrical, if you have electrical students friends, then let them know Creatrix, Gate, IANS, Triple E, double E, this particular channel is available for electrical students. This particular channel is available for mechanical. People are working very hard for those members who are in the respective branch. For civil, for computer science, this channel अपना आपका अपना चैनल है यार ये. हम सिर्फ और सिर्फ आप तक इंफॉर्मेशन पहुंचाते हैं, सिर्फ आपके जस्ट चैनल, योर चैनल ओनली, एंड वर्क फॉर